The next type of problem is adding and subtracting rational expressions. Rational expressions means expressions with a numerator and a denominator that are polynomials. And in this one, we're going to simplify. So we need to simplify. We don't have to solve. There's no equal sign. It's just simplify. So the first step is you want to factor any term that factors. So this one right here is going to factor out. I notice anytime you see like x squared x number, there's a pretty good chance that's going to factor. You know, it's in that ABC form. Sometimes you have to watch and see if they both multiply by something, and these don't, right? You would have to pull that out. Like if it was 2x minus 8 right here, you'd have to pull the 2 out. But there isn't one like that on this particular problem. But this definitely factors, so we're going to factor that right there. So let's go ahead and start factoring. We're going to look at this one right here, this little blue section. And I'm going to rewrite this whole thing. So we got 2x over x minus 4. And watch, when I rewrite this, I'm going to leave a little space like that. And leave a little space on each one because you're going to have to multiply terms later, so you need some space to multiply them. Minus 10 over, and I'm going to factor this. So I'm going to rewrite it factored. So I'm going to set, this is a times c, which is 1 times 8, that's 8. This is b, this is negative 6. So what two numbers multiply and give me give me 8, and add and give me negative 6? What multiplies gives you 8? 1 and 8, 2 and 4. 2 and 4 could give me 6. So 2 and 4, and they both need to be negative, because if they're both negative, that's x. That is negative 2 times negative 4 is positive 8. Negative 2 plus negative 4 is negative 6. So I have x minus 2, x minus 4. So that's the first step, to factor everything out and get it in its smallest factored terms. The next step is I need to find all the common multiples to make the denominators equal. So I have multiples here. I have x minus 2 and x minus 4, right? This one has just x minus 4. It still needs x minus 2 to be the same as this other one. So what I'm going to do is I'm going to multiply it times x minus 2. So because now they're the same. See, this is x minus 2 times x minus 4. This is x minus 2 times x minus 4. But if you're going to do that to a fraction, if you put an x minus 2 on the bottom, you have to put an x minus 2 at the top like that right there. So now they're all equal, right? And once the denominators are equal, when you're adding and subtracting fractions, you can go ahead and combine these two fractions now. So this is going to be equal to, and the denominator, when you add or subtract fractions, stays the same. So the denominator is going to be x minus 4, x minus 2. All right? So let's look at the top here. I'm going to distribute that right there. 2x times x is 2x squared. And 2x times negative 2 is minus 4x. And then minus 10 on the end here, because now I can subtract that 10. I'll do minus 10. All right, so I have 2x squared minus 4x minus 10. And this would be an acceptable, correct answer if you were to write it, but you could also do this. Now, the same way that I factored this x squared plus minus 6x plus 8 and turned it into x minus 2, x minus 4, I could FOIL it back. If you did FOIL and multiplied this out, you'd get x squared minus 6x plus 8. So I could go back like that and make that my answer. This is also an acceptable answer because they're equivalent to each other. Minus 10 divided by x squared minus 6x plus 8. Both of those are acceptable answers on this problem. All right, so this is adding and subtracting rational expressions when you're just simplifying it.